Okay, sodium has a work function of 2.3 electron volt. Calculate its threshold frequency. Okay, let us do the first question. Let us do the first question. So sodium has a work function. This sodium is a metal. Yeah, it's a metal. So work function is we call the binding energy for sodium. Yeah, towards the free electrons. Okay, so we have to overcome this work function in order to release the free electron from the metal surface. Okay, so work function. Okay, so let us put this. This is the work function W naught. Okay, the unit is electron volt. We might have to convert to joule later on. Yeah, let's see. Yeah, calculate the threshold frequency. Okay, so let's look at the equation. So work function is actually HF naught, yeah, or Hc over lambda naught. Yeah, work function of metal surface. W naught is the energy minimum, okay, to release the electron from metal. It is equal to Hf naught. F naught is the threshold frequency, and then also equal to Hc over lambda naught. Lambda naught is the threshold wavelength. So if the question want to find the threshold frequency, which is F naught, okay, this is the one, F naught. So you just use this equation, W naught equal to Hf naught. Okay, then you can find the threshold frequency. All right, so let us use the equation. A naught, question A, W naught equal to Hf naught. However, remember this equation, W equal to Hf naught or E equal to Hf, this equation is unit, SI unit, joule. It is in SI unit. The energy is in SI unit, joule, and the left hand side is joule. The right hand side also end up with joule unit. Yeah. So you must first convert the electron volt unit to joule unit by multiply electron charge. Okay, so you have to convert it to joule first. Convert the energy to joule first before you can substitute the energy value into the equation. Understand? So same goes to this equation. W equal to Hf naught. The W, this one must be in SI unit, joule. Okay, so remember this one must be in unit joule because we know that the H is joule second, and then you see that the H is in joule second. See that the unit in joule second, and then frequency is per second. So as you can see here, the unit cut off. So this unit is in joule. This entire equation is in SI unit. SI unit. So you cannot substitute electron volt directly into W naught. Cannot. Yeah. You must convert this electron volt to joule first. You must first convert it to joule. Then only you can substitute this value into W naught. Okay. So as we remember, for the energy unit, we have okay, and I think I just copy from the next door. Yeah, from the next door I have I write this. So I just make use of this. Yeah, over here. Let me put it over here. Yeah. So energy has two units. It's either electron volt or joule. Electron volt or joule. So you need to first convert the electron volt to joule by multiply electron charge. Okay. Then once you got the unit of energy, the work function in unit joule, then only can substitute into this equation. Okay. Remember, don't substitute electron volt into it. Don't substitute electron volt into it. It's wrong. Okay. Or in SI unit, joule. All right. Okay. Let's work it out. Yeah. So okay, we have the work function which is 2.300 electron volt. So to convert to to convert to joule, we multiply by electron. Yeah, we multiply by electron charge. So okay, after multiply, what do I get? Yeah, after multiply, what do I get? Let's calculate. Yeah, multiply electron charge. Electron charge is this is the electron charge lah. See that? Electron charge. Electron charge is 1.6 exponent negative 19 coulomb. You can find all this value in the list of constant. You understand? You can find all this value in the list of constant provided in the exam. You can find all this value in the list of constant provided in the exam. So including the electron charge, 1.6 negative 19 coulomb. Okay, so 2.3 multiply 1.6 exponent negative 19. So 2.3 multiply 1.6 exponent negative 19. Yeah. Let me write it down. I write down over here 2.3 multiply by 1.6 exponent negative 19. Then only you get unit joule. Understand? This is the electron charge. Okay, so what's the answer? Yeah, after I multiply, so it is 3.68 exponent negative 19 joule. I got the work function in unit joule. Then only I can substitute this one into the equation. I can substitute this one into equation. So let's substitute. Yeah, so let's substitute. So we use the formula W naught equal to HF naught. Okay, so we substitute the unit joule. Okay, the answer in joule, negative 19 joule. The work function must be in joule. Remember, must be in joule. And then the Planck's constant is 6.63. See that the Planck's constant 6.63 negative 34. Exponent negative 34. This one is joule second. Okay, and then we can find the threshold frequency. So what's your threshold frequency? Let's calculate. Yeah, threshold frequency. So I divide 3.68 exponent negative 19. I divide by this 6.63 exponent negative 34. So the answer is 5.551 lah, 5.1551 exponent 14 hertz or per second. So that's the frequency. Okay, do I have the answer? I don't have the answer with me. Yeah. Okay, never mind. So that's the answer. Yeah, that's the threshold frequency. Now, okay, let's continue. Want to find the okay, we got the threshold frequency already. So we want to find what? Calculate the maximum speed of the photoelectron produced when the sodium is illuminated by the light of wavelength 500 nanometer. Okay, so this light of wavelength, this is called the incident light. Incident light. Yeah. So is this phenomenon? Where is it? Let me show you. The incident light. This is the one. Understand? Einstein photoelectric equation. So you can see here. This is the incident light coming. This incident light photon carry amount of energy HF. Is used to eject. Provide this photon, incident photon, is trying to provide energy for the free electron in order to overcome the work function of the metal. Work function is the binding energy of the metal. So once it overcome the work function, it receive enough energy from the incident photon, overcome the work function, and then it can eject from the metal surface with certain kinetic energy. Understand? So this is the incident photon, is to provide energy for the free electron to overcome the work function and ejected with certain kinetic energy. Okay, so that's the incident photon, illuminated by light of wavelength of 500 nanometer. So this is the incident light. Yeah. So we want to find maximum speed. Maximum speed is Vmax. Vmax. So Vmax is related to Kmax, kinetic energy, isn't it? Yeah. Maximum speed of the photoelectron produced, or we can say ejected lah. Ejected from the metal surface. That means already overcome the work function. Yeah, to be ejected from the metal surface. So we want to find the Vmax. So how? Go back to our photoelectric equation, which is this equation, E equal to Kmax plus W naught. Alright, this is the equation. Okay, so E equal to Kmax plus work function. So as you can see, this Kmax is related to the Vmax. This Kmax is related to the Vmax. The maximum speed. This is the maximum kinetic energy. So Kmax is equal to half mv square. Kmax is equal to half mv square. So we can find the Vmax from the Kmax. But we must use this photoelectric equation. Substitute all the value like work function, the energy for incident photon, substitute. Then only you can find the value of the Kmax. Once we got the value of Kmax, we find the value of Vmax. Understand? Okay, so let's use this photoelectric equation. Okay, let's do it. So question B. So we're going to use this formula equal to Kmax plus work function. Okay. So remember, E is the energy of incident photon, Kmax is the maximum kinetic energy of ejected photoelectron, and W naught is the binding energy or work function of metal surface. Okay. Now I can substitute this E. Okay, I can write it over here. This E is also I can write it with never mind. Continue. This E is also HF or HC over lambda. Understand? Okay. So this is the one. Never mind, let me write it somewhere else. Okay. So this is the one. Where should I write? Yeah, where should I write? Maybe I just put it here. Okay. You understand? And then this one. Okay. This Kmax is you can put it as this Kmax is half mv max square. Understand? This Kmax is half mv square, or we can also say this is EVS. The stopping potential is here. And then of course W naught is HF naught or HC over lambda naught. So this work function here, you can find the threshold frequency, and you also can find the threshold wavelength. I can find from W naught here. Vmax you can find from the maximum kinetic energy. Vmax you can find from Kmax here. Kmax is equal to half mv square, and VS is stopping potential. Stopping potential also you can find from Kmax here. Yeah, find from Kmax here. And then this is the frequency of incident photon, and then this is the wavelength of incident photon. You can find from the energy of incident photon here. Energy of incident photon. Vmax and stopping potential you find from Kmax. Yeah, threshold frequency and threshold wavelength you find from the work function. Understand? Okay, right now I want to find want to find the maximum speed. So maybe this one E I can just substitute with light of incident wavelength. Yeah, so we have the incident wavelength. This is the lambda. Yeah, and this is the lambda wavelength. Understand? The lambda. So I can use this formula. I can substitute E with this one, HC over lambda, E equal to HC over lambda, And then I want to find a Vmax, isn't it? So I substitute the Kmax with half mv square, half mv square. So I can, and then I can do, yeah. And then work function, I just use this lah, because I already have the work function. Okay, work function. Well, so what do I need? What is the unit I should put? So it's better if you maintain all in joule, because why? Because you see this hc over lambda here, you get the unit joule. Joule, so energy you get from here is joule. Understand? So it's better you put everything in joule lah. All this unit in joule, joule. All this unit in joule. Okay? Because we want to maintain same unit. So we make sure all this in unit joule. Okay? Because your hc over lambda is in joule. So this energy you put joule. So that means because here work function give you electron volt, isn't it? Electron volt. So don't put work function with electron volt. Yeah. Put the one with joule unit. We already calculate the work function in joule unit. Yeah, joule unit. So just substitute this value of work function with joule unit. Okay. Don't substitute this electron volt into here. Change it to joule. So use the work function with joule unit into here. Yeah, because we want to tally with this energy. They must all have the same unit. Yeah, all must have the same unit. Cannot add electron volt with joule. Yeah, you can only add joule with joule. So this energy also must be in joule because hc over lambda is in joule. Understand? Okay, so use this value. Yeah, use this value. Use the one with joule unit. Yeah. Okay, don't use the electron volt. Okay. So all right. So okay, I can change this formula into hc over lambda. hc over lambda equal to, because I want to find Vmax, I just change the Kmax into half mv max square, and then plus work function. Okay, just tailor to our need. Okay, so okay, my h is 6.63. I substitute that one. 6.63 exponent negative 34. This one in unit joule second. Speed of light c is 3 exponent 8. And then divided by the wavelength. Okay, what's the wavelength? Yeah, okay, let me adjust a little bit. Okay, the wavelength, you see, light of incident wavelength. Yeah, the incident light of wavelength 500 nanometer. Nanometer change to SI unit also. Okay, make sure all in SI unit. Yeah, all in SI unit. So including the unit joule. Okay. So your work function also must be in joule lah. The work function also must be in joule. Okay. All in SI unit joule. Okay. So lambda is 500 nanometer. So substitute 500 nanometer. Okay. Let me write carefully. 500 nanometer. Nano is negative 9. Okay. Negative 9 meter. Okay. I done it. So half. And then this is mass of electron lah. This is the mass. This of course is the mass of electron because this is the Kmax is the maximum kinetic energy of the photoelectron ejected. It's electron. So this mass is the mass of photoelectron. Mass of photoelectron or mass of electron is 9.11 exponent negative 31. Okay, substitute that value also. Mass of electron. This is mass of electron. 9.11 exponent negative 31. Okay. Then Vmax. We want to calculate the Vmax. And then don't forget the square lah. Yeah, don't forget you have a square here. And then work function. What's the work function? Work function is 3.68 exponent negative 19. 3.68 exponent negative 19. This one in unit joule. Understand? Make sure all unit in joule. Okay, all in SI unit. All in SI unit. Okay, so okay, so I think I can calculate. So I think I just calculate this one first. Okay, step by step. 6.63 exponent negative 34 multiplied by 3 exponent 8, and then divided by 500 exponent negative 9. So this is 3.9. Oops, 3.978 exponent negative 19 joule unit. Okay, and then half. Okay, just calculate this one first. 9.11 exponent negative 31. 9.11 exponent negative 31 divided by 2 or multiply half lah. So you get this one 4.555 exponent negative 31. Okay, V max square, understand? And then 3.68 exponent negative 19 joule also. Okay, so now calculate 3.978 exponent negative 19 minus 3.68 exponent negative 19. Okay, and then I divide by 4.555 exponent negative 31. Okay, and then I square root. Don't forget. So what you get here is just Vmax. Understand? What you get here is just Vmax. So you still have a square. You still have a square you need to deal with. You have a square. Understand? You get your answer in Vmax. So don't forget to square root. Many students forget to square root. Okay, to square root. So once I square root the answer, the answer is actually, the Vmax is actually 2.56 exponent 2.56 exponent this exponent 5, yeah, exponent 5, 2.56 exponent 5 meter per second. So that's the maximum speed. I got it. Okay, there's no answer here. Okay, never mind. So I just accept what it is. Yeah, 2.56 exponent 5 exponent 5 meter per second. That's the maximum speed of the photoelectron ejected. Now I want to find the stopping potential with light of this wavelength. So what is the stopping potential? Stopping potential is Vs. Vs. So Vs I can find from where? From the Kmax. Vs I can find from Kmax. Understand? Just remember this one. Kmax can change to half mv max square or can change to EVS. So Kmax, so stopping potential Vs you can find from Kmax. Understand? So I just make use of this one. Okay, just make use of this one again. So just substitute over here. Okay, this one I copy and then I substitute here. Okay, right. So this one I'm going to use this. So okay, so now I'm going to use between Kmax and what? And EVS. Understand? I'm going to use that one. Kmax. I already have Kmax, isn't it? Do I have a Kmax? Have you calculated the Kmax yet? Oh, I jump straight away, right? Oh, that means it's okay. Since I have the Vmax, I just use the Vmax lah. I just use the Vmax. Never mind. Just use the Vmax and can find my EVS, my stopping potential Vs. So that's question C. Yeah, question C. So okay, I have the Vmax. So then mass of electron. This is the mass of electron. Remember, this is the mass of electron. Mass of electron is 9.11 exponent negative 31. Okay, 9.11 exponent negative 31 kilogram. Okay, this is in SI unit kilogram. Okay, and then Vmax, just now I calculated 2.56 exponent 5 square, yeah? So quiz exponent 5, yeah, exponent 5. Okay, so equal to, don't forget the square, don't forget you have the square here. And then EVS, E is the electron charge. E is the electron charge, 1.6 exponent negative 19 coulomb. Multiply the stopping potential. So I can find my stopping potential. So, okay, so 9.11 exponent negative 31, negative 31 multiplied by this one, 2.56 exponent 5 square. Don't forget the square, yeah? 2.56 exponent 5 square, and then divide by 2, and then divide by the electron charge again. 1.6 exponent negative 19, 19, yeah, 1.6 exponent negative 19. So I got my stopping potential, which is 0.187 volts. That's my stopping potential. Okay, so that should do it. Yeah. Okay, so that's the answer for everything. Yeah, hope you understand. Yeah, stopping potential with this wavelength. So that's the stopping potential you can get from the Kmax or half mv max square. Okay, so that's the answer. You got the threshold frequency, you got the maximum speed, and you also got the last one, stopping potential, stopping potential, or we call it stopping voltage. All right, so that's all. Okay, bye bye.